Hello, my name is Gabriel. I'll be talking to you today about what happens to your code after you're done implementing a feature, namely how you get it out there and running. In particular, I'll be talking how to encode certain steps of this process inside your build tool, which most of you should be familiar with, SBT. First about myself. Yeah, I'm a software developer working for Ovo Energy. Ovo Energy is a company based in London. It's an energy supplier, over 1 million customers with a focus on green energy, offices in London and Bristol, and a lot of interesting technologies, I think. Find me afterwards if you're interested more. All right, and now to the topic of today. So before anything, I'd like to do a quick introduction to SBT. It stands for Simple Build Tool. Like any build tool, it does a few things for you. So we know that the compiler is what takes your code and generates some machine interpretable files in Scala, that is .class files, bytecode to be run on the JVM. But as soon as your project gets bigger than a few source files, you need some kind of tool to manage this compilation process for you. What other things a build tool might do for you is organize your tests, run your tests, and manage your dependencies, bring in external code and external bytecode for you that your application relies on. SBT in particular differentiates itself from other build tools by being a build tool written in Scala for Scala and mixed Scala and Java projects. The fact that it's written in Scala means you can reuse a lot of the syntax you're using during your code, your day-to-day code inside your build definition. And important for this presentation is that it's extensible using plugins. To get started with SBT, for Mac users, it's just brew install, and you can use a template to create a Git template to create a new project, or you can just use IntelliJ, which comes integrated with SBT. For non-Mac users, you can also use a Debian package for Linux, or you can download the installer from the website if you're a Windows user. I won't go through every single feature of SBT today, because it's quite a complex piece of software despite its name, but I will talk about two things which should enable you to follow the presentation today. First of all, SBT projects come with a certain directory structure. Important for today is the build.sbt, obviously. This is the heart of your build definition. That's the file where, for small projects, that's the only file you'll be interested in. But we also care about the project folder, namely Scala source files in here, which are placed inside this project folder, can be used from your build.sbt. And importantly, the plugins.sbt defines the plugins which you're bringing into your project. The version.sbt will also become relevant later, but I'll come back to that. And the second thing I want to mention is that SBT configuration files are basically organized around this one key feature of configurations which have a key and a body. So basically most of what you do in your build.sbt will be setting certain keys. There are two kinds of keys. Setting keys are only computed once, whereas task keys involve things that are reevaluated every time you compute. So think of the difference between values and vals and defs in your normal Scala code. Settings will be a lot of your configuration, such as the organization, as in the picture, and task key will be something like compile, which you can think of conceptually as a task. All right, so what do we mean by deploying? Normally start with your code, and what do you want to do with it? First thing, the compiler can transform this. For Scala, your compiler will produce .class files. So far, so good, but maybe you want to do something more than that. You want perhaps to package your application as a Docker image to run as a container. And when you do that, you'll have some kind of versioning. You'll want to push this to a container registry, and you'll have some kind of versioning scheme you want to maintain. Meanwhile, in the same project, or more likely in a different one, you might want to release your code as a library, and then push to some kind of library repository like Bintray, and this will have its own version management scheme. So this is obviously quite an arbitrary example, but it will be what we'll be following today, and hopefully trying to draw some more generalized lessons as well. So, brief introduction to Docker. Docker is an abstraction over applications. It's the idea is that you can build it somewhere and then run anywhere. So you package your application together with any dependencies it might need, and then you can run it either in the cloud or on your local machine or anywhere else. The closest thing you might relate to is a virtual image, but this is one step more lightweight than that and more easier and smaller to run. While obviously as a Scala developers, we don't build any kind of application. We'll always be building something we want to run on the JVM. Because this is a more and more popular tool, a lot of tools will expect a Docker image, so you might have good reason to want to transform your Scala app into a Docker image. So introducing the first plugin I'll be talking about today is sbt-native-packager, which does just this. It's a SBT plugin that will build your application into various kinds of native formats. You might want a Debian app, but for the purposes of this talk, we'll be concentrating on this Docker example. So what do you actually need to do in your code? You need to do very little, in fact. So importantly, you need to go to your plugins.sbt inside your project folder and add this particular line just so your SBT can bring in its plugin. Next, what you're interested in is two things. It's firstly enabling the Docker plugin, because as I said, the plugin itself enables multiple kinds of formats, and then you have a few settings to set. This is what you would expect if you're familiar with Docker. You want the name of the image, you want a certain repository to release it in. Today we'll be using Google Container Registry. You might want your maintainer, and you will definitely want a base image. A base image usually will be just something which has a JVM on it. And importantly, this file sits in the project folder, and that's why what I define here, namely this function with Docker, I'll be able to invoke in my build.sbt. So, of course, maybe this step of indirection is obviously not necessary. I chose to work this way to give some kind of modularity to what I'll be doing today. So here you're only interested in the last line. All right, so let's see that in action. All you have to do once you have that in your project is run this sbt command. If you remember this will take around 30-40 seconds. If you remember what I said earlier about settings and tasks, the things I said before are settings, but this one is a task. Obviously, it's something conceptually that you're running, that you will be run when you ask it to. All right, that went through. No, that was just the build. Now we're actually constructing the Docker image. And this probably goes quite quickly because I've done this before on this machine, which is convenient. And should be a few seconds now. There you go. That's the push. And success. And if I can show you that it actually worked, if I refresh my GCR, you should be able to see just now uploaded. So that was it. That was all it took to get an image to my Docker container. There are the things you might want to do after you have your image in the container registry, but I will not be talking about that today. All right, so what else might your release process involve except publishing your Docker image? I mentioned at the beginning something like version management, and you saw earlier on the Google Container Registry that I published something with a .snapshot suffix. It did that because that's what the version setting referred to, and that it took in turn from the version.sbt file. But when I'm doing an official release, I might want to get that suffix out and then also make sure that I update it when before I leave, so that the next version will have incremented. So for this, I'll introduce the sbt-release plugin, which is a plugin that basically handles this stuff. Creates a release, which is a sequence of all kinds of stuff you might want. So this is like what a simple SBT release definition might look like. There are, again, a few settings you're interested in. But again, the one setting I'm interested in is this one, the release process, which has a type of sequence of release steps. The plugin provides you with some common steps you might want to use. So most of what you see here, so you will want to check snapshot dependencies to make sure you don't release something which relies on snapshot dependencies in your production. We might want to run the tests. You'll want to set the release version, as I said earlier, remove that snapshot suffix, and afterwards upgrade the version, tag it, and so on. What I wanted to show you is that this is also a method provided by sbt-release, which allows you to introduce a custom command. So in our case, this Docker publish is what I showed you earlier. So I'm using this sbt-release plugin configuration to invoke Docker publish, which uses the previous plugin I showed you. Same pattern here. I defined something inside my project folder, and I'm using it inside my build.sbt. And I'm going to show you again. Before I didn't mention, but there was a prerequisite of having authentication to Google Container Registry. Now, obviously, I also need remote repository push permission, so I can update that version not just on my local machine, but also in GitHub. So I'll be showing that. SBT. So this will take a bit longer. Again, back to what I was saying at the very beginning, the fact that this is all Scala code, you get full access to the Scala syntax. And indeed, not in my team, but at work, some people use this ability to create a more sophisticated versioning patterns. For instance, they look for, if you put some kind of string inside your release message, then it'll just handle it as a minor version update for you. And you can do even more interesting stuff as well. So this is basically what the Docker publish step we were seeing earlier. Repeated, but this time without the snapshot suffix. So it's publishing as if it were for real. Now it's updating the version to 0.3.6 snapshot, and there you go. So now if we look, first if we look here, we should have a 0.3.6 in my container, no, 5, correct. 5 in my container registry, so you see just now, and also a new tag over here in my GitHub. Yeah, there you go. Okay, moving on. As I mentioned in the initial diagram, one other thing you might want to do with your code is publish it as a library. And this is actually possible without any kind of plugins, but this SBT bin tray plugin makes it even easier than it would already be to publish to bin tray. Again, all you need to set is a few settings. This is an unfortunate artifact of me trying to use multiple modules, and this kind of clashes with the Docker publish. But again, you only need to mention the repository, whether an organization, and yeah, the package name, basically. You also need your credentials somewhere. This is my new build.sbt, where I'm trying to do a multi-module project that has a library as well as a Docker release. And this also changes that release step sequence I put earlier. Everything else stays the same, but I have both a publish artifacts command and a release step Docker publish. So I'm going to actually skip this demo. But yeah, now this adds in one more prerequisite as well as the earlier ones, which you need to take care of before you want this to be successful. And now I've done all that, what do I gain from putting? It was quite a bit of work by the end of it, especially with a multi-module project build.sbt. So what do I get from this? A lot of the stuff I showed you today, one would normally do inside a CI/CD tool such as Circle CI or Travis CI or Jenkins, and that's good, and it's still a more than recommended way to do it. But I want to show you that if you do it this way in SBT with syntax you might be more familiar with, you can have a very, very concise continuous integration pipeline definition. Namely, basically one step here does all the work, which is sbt-release with defaults I showed you earlier, and the other steps are to meet those prerequisites I talked about earlier. For here we assure we can connect to my container registry. And here, unfortunately, this took a few more steps than it would be pretty, but this allows me to push to my remote on GitHub. So actually, for the purposes of this talk, I want to prove myself that this actually makes it easy to write a CI/CD pipeline. I never used Travis CI before. I used Circle CI at work, but I wanted to see how quickly I can get this done, given that I've done all the work in SBT, and I think it only took me like 20, 30 minutes to get this running. I thought that was pretty nice. So to summarize what I talked about today, I've filled in the missing steps from the starting diagram. You can use sbt-native-packager to construct native, to build to certain native formats like Docker. sbt-release has some nice steps which take care of your versioning. sbt-bintray, not mandatory, but you can use this to release to bintray. And yeah, I think that was pretty quick. So takeaways. First of all, I want but I hope I've convinced you that this is relatively easy. This is one of those things that maybe, at least there was a time at my work where it was always the kind of thing you copy-paste from one project to the other. When you create a new one, you don't really think about it, and then when you need to change a thing, you don't really know what you're doing. So it was useful to put it in order and learn it exactly what's going on so I can show it to others. The power and convenience of SBT Scala code. Maybe I didn't showcase this precisely today, but you must have recognized certain structures like the sequence of release steps, even if you hadn't worked inside SBT before just by working with Scala code. And extensibility. Here, I don't mean that just that some people wrote plugins and you could bring them, but hopefully after a few of my slides, you recognize that the pattern was very much the same. You brought a new plugin, it had some settings, you could have checked the documentation to know which, and then it just did its job. So maybe this will help you be less afraid of bringing a SBT plugin that can make your life easier. All right, and that would be it for today. I definitely recommend checking out each individual plugin I talked about today. If you want my slides, you can find them at that GitHub link. And also, while SBT is, I think, a fairly convenient tool, it's important probably to go through the docs at least once. It's not that simple, but yeah. That would be it for today.
Thank you very much. Okay. So we have 2 questions for you. The first one is how to externalize application version, for example, to set version by CI.
If you want that, I could assume you could do something like environment variables, which we do at work for other things in certain teams. Can you work with Docker files as well? I mean, guess this kind of, in my mind, this replaces the work you do by building your own Docker file. So, I mean, once you have a Docker file, I don't know what the native packager would do for you, but perhaps I'm not thinking of this right. I don't know. Sorry. And the next question?
Yeah, and the last one is how to hide sonotype creds.
So I was using the Travis CI to provide me with the credentials.
Yeah.
Hope that answers.
So I guess that's all. Thank you very much. Ladies and gentlemen, please give another round of applause for our speaker. Thank you.